Hi everyone! In this video I'm going to do the example problem in the notes that are posted. So I have f of x equals x squared and I'm asked to compute f prime of 2. That's how I would say this term right here is f prime of 2, and that's also the derivative of f at 2. So I'm going to use the definition of the derivative that we had on a previous page, and we'll note that in that definition my c value is that 2 right there. So that means that f prime of 2 is the limit as h approaches 0. That's how all these problems will start. And I have f of 2 plus h minus f of 2 divided by h. So that would be my first line if I was asked to find the derivative of any function at 2. And now my next step is I need to do some work to find what f of 2 plus h is. That'll have an h in it. And then find what f of 2 is. That'll just be a number. And then plug those into both of those spots so that I can continue. Alright, so f of 2, I'll do some work on the side. F of 2 in this function is 2 squared, which is 4. So that's what I'm going to plug in right here for f of 2. I'll put a 4 in the next line. F of 2 plus h is a little bit weirder, but we're going to get the hang of plugging in stuff like this. So f of x equals x squared. That tells me that f of anything equals that thing squared. So when I put 2 plus h in there, it'll be 2 plus h all squared. Like that. So I can't distribute this 2 exponent. To expand this out in the next step, I'm going to have to FOIL 2 plus h squared. So you can either save that for the next step, or you can do it right now in the scratch work. I'll save it for the next step. Alright, so I'm going to fill in each of those 2 pieces. So now f of 2 plus h is filled in with 2 plus h squared, and f of 2 has been filled in with 4. And I'm still just attempting to compute a limit. The problem is that you can't just plug in h equals 0 here because it would make you divide by 0. But even though it doesn't look like it right now, 0 is a hole in this graph. So what we want to do is mess with that numerator enough that we can see the h's cancel. And then as soon as the h's cancel, we can plug in h equals 0 and be done. Right. So this is the step where I need to FOIL out 2 plus h squared if I haven't already done it, which I haven't. So I'm going to work on the side again. 2 plus h squared. So that's 2 plus h times 2 plus h. That will give me first, outer, inner, and last. And I can simplify the plus 2h plus 2h. I can make that a plus 4h. So this 4 plus 4h plus h squared is what I'm going to plug in this spot in the next step. So all of that goes here. All right, and we'll see what we have. So I'll continue carrying down that limit as h approaches 0. 2 plus h squared is now 4 plus 4h plus h squared. And then this minus 4 is going to come right down. Alright, so on the top of this fraction now, you can see 4 and negative 4. These completely cancel out. And that's actually where the magic is, because once we get rid of those 4s, what we have left is 4h plus h squared over h. And now you can start to see how that denominator h is going to cancel. So if from here you want to just cancel one h from each of these three terms, you're welcome to do that. Or you could actually factor the numerator, which is what I'll do. So 4h plus h squared. You can see this as factoring, or you can see it as just kind of undistributing or factoring out the h. So 4h would have a 4 left over, and then h squared would have 1h left over here. So you can see that if I distributed this at h into the parentheses, I'd have h times 4 plus h times h, I'd end up with what I have up here. And now in this form, I can see h over h cancels. I really did have a hole at h equals 0. So this limit should equal that limit. And 4 plus h is something that I can plug in h equals 0. So that's what I'm going to do. And I'll just get 4 plus 0. My final answer is 4. One last thing I want to point out before we finish is in this step here, when I canceled the h's, it can sometimes be weird when the only thing in the denominator or the numerator cancels away. What's left when you do that is a 1. So if things ever get weird, it's a 1 in that spot after it cancels. So my final answer to this problem is that f prime of 2 equals 4 when f of x equals x squared.